Hello, my friends. Welcome to the Whitby Public Library's Giant Science online program. My name is Sherry and I work at the Brooklyn branch. Today we are going to explore bubble science. Bubbles can be fun and fascinating for children of all ages. However, this program is intended for children between grades 1 and 4. Parents, we ask that you ensure small children do not ingest the bubble solution if you are trying this at home. The supplies you'll need are included in the description. After much research, I found a recipe that everyone can do with simple ingredients that they have at home. You are going to need half a cup of sugar, 1 cup of water, and a 1/4 cup of Dawn or dishwashing soap. Many of the bubbles that you can buy in the store have something called glycerin inside of them to make them long lasting. Because not many people have glycerin at home, that's what the sugar will do in your bubble solution. I'm just going to measure out. I've put in the water and the sugar already. So I'm going to measure out a 1/4 cup of my dish detergent. And I'm going to add that to our solution. And then we are going to take a stirring implement and we're going to stir. Now I've already made this solution up because it's best to set it aside and let it set for about 24 hours for it to work the best. But when you're stirring it, what you want to do is to make sure that all the sugar is dissolved. Now the great thing about this recipe is that it can be scaled up or down for more bubbles or a smaller amount of bubbles. For example, instead of just 1 cup of water, you can use 2 cups of water, and then you would use 2 1/2 cups or a cup of sugar and 2 1/4 cups or a 1/2 cup of dish detergent. This will be especially good if you're making it for more people to play with. Okay, I'm just going to set this one aside. And this is the solution that I made yesterday. So let's just move our measuring tools out of the way and put our ingredients aside. Now, I haven't put in the glycerin yet. So if you do have glycerin, you can add this. What the glycerin and sugar do is it makes the bubbles evaporate less quickly. So let's add a tablespoon of glycerin into our solution. And we'll put that aside as well. And we'll give it a stir. Now, let's talk about the science of bubbles. Scientists have a method of work that they call the scientific method. So they look at something and they watch it and they see what it does. And they ask, what do they see? And they think about questions about what they are seeing. Questions like, what is it like? How did it get that way? Why is it like that? So let's look at our bubbles and think about questions that we can ask and we can explore. You've probably played with bubbles 100 times in your backyard. But did you know what kind of science can be seen using bubbles? Well, let's start with the states of matter. Do you know how many states of matter there are? That's right, there's 3. Everything around us is made of particles, and they can be either solids, liquids, or gas. Solids are kind of hard, and liquids fill a container, and gas is in the air around us. Can you think of examples of solids? Well, we have my table as a solid, I'm a solid, and you're a solid too. And they're often hard. Liquids, we have water, we have dish soap, those are liquids. But what about the air? Can we see it? Can we see gases? And do gases really take up space? Well, bubbles are proof that gases have mass. It's easy to see that in our measuring cup that liquids do, and that solids take up space. I take up space. But how can you show that air and gases take up space? Well, let's give it a try. I have some fun bubble wands here, so let's give a couple of them a try. Let's dip them into our bubble solution. And there they are. The air that we have in us is filling up and stretching the skin of the balloon. Let's give this one a try because it's fun. There we go. How much space is that bubble taking up? Well, there are equations that you'll learn later on in life that will give you the exact mass of the gas inside of a bubble. But for now, we're just going to try with a measurement. So you're going to need a plate and a ruler. I've got my big sewing ruler here. And some Sharpie markers. Now I've already set up my plate with a grid going up and down and side to side. I've used inches, but you can use centimeters for yours. And what we're going to do is we're going to take our bubble solution and we are going to blow a bubble into the middle of the plate. Oops, let's try that again. And see how they pop? Oops, that didn't work very well. Wow, Carmelo Piazza, who's known as the science fellow, has a very good rule about bubbles. If you touch them and it's dry, bubbles go bye-bye. But if you touch them when they're wet, they don't get upset. So one of the other things that I have on my table is my spray bottle, and it's just filled with some water. So I'm going to push a little bit of spray into there, a little bit of water in, and then let's give this another try. And there it is. So it's actually almost the diameter of the plate, which is about 7 inches. Now, I have a glass. There's a glass down here as well. Let's spray that with some water. Make sure it's nice and wet. And let's give it a try again. And as long as the glass is wet, the bubble could keep blowing. And that was just that little tip. So that skin of the bubble has just expanded from that small amount of bubble solution that we had. Now, we talked about wet and dry. My straw is wet, and look, I can stab that bubble. I think it's a little bit dry up top, so let's kind of get that wet up there too for the next time. Let's try it again. Once more. And there we have a bubble. And we can cut it with the straw because the straw is wet. What would happen if we added more air into that bubble? Well, look at that. Bubble in a bubble. And can we do it again? We sure can. How about we try it once more? Let's put a little more bubble solution on there. And let's try blowing some more bubble solution in and see what happens. and there's a bubble in a bubble. Do you think we could try it again? Let's give it another go. Oh. If they touch each other, they bounce out. There is a bubble in a bubble. Let's try it once more. And in a bubble. Bubble inception. The next experiment that we're going to do today, we're going to explore tensile structures. Now, the bubbles that we blew today were all round. See that? Round, all round bubbles. But can we make a square bubble? Well, I found a wonderful instruction on how to make a square bubble using pipe cleaner and straws. Again, I will include the link to these directions in the description below. So what I've done is I've created a cube out of the straws. Tensile structures are formed when a material or cable is stretched and held in tension between two or more anchors. Can you think of some tensile structures that we might already see in architecture out in buildings? The canopy that maybe mom and dad have set up in the backyard is actually a tensile structure. Teepees and wigwams, the indigenous knew tensile structures a long time ago. They used a frame and covered it. Suspension bridges are tensile structures. Sailboats that have the large sail in between their mast and the yardarm is a tensile structure. So we're going to try this experiment with this tensile structure wand. Let's see. So I'm going to move this one. I'll put it over there. And we're going to dip our wand into our bubble solution. Let's see, make sure everything gets in there. And then, if you can see, there is actually a bubble built inside, stretched between our cube wand. You see that? There's actually a bubble in there that is square. And the anchors are the size of the cube, and the bubbles have joined in the center, which is really, really cool. I'm going to put that there. And I have a pyramid-shaped wand made out of straws again, using triangles. And let's see what it shapes up. And there it is. This shape is actually called a tetrahedron, and it is a triangular pyramid. So that's really cool as well. There are so many experiments that we can do with different wands and testing different bubble solutions and using wet and dry and adding different gases. When we blow out, we're expelling carbon dioxide. But what about if we just wave our wand in the air and just pick up the air that's there? Some great questions to ask. I hope you've had a lot of fun today learning about bubbles. Make your own recipe at home and explore bubble science. Have fun, but remember to ask questions in the scientific method. Thank you so much for joining us today. Follow us on social media or visit us at whitbylibrary.ca for more online programs and information about our collections. Have a great day.